was known as the Carrington event that occurred in 1859. And although they didn't have a lot of electronics back then, there was some effects, and you could see auroras all the way down to the Caribbean. More recently, not Carrington level, was one that happened in Quebec in 1989 and then knocked out the power grid for a good 12 hours. And in 2012, there was a Carrington level event that just missed the Earth, and it was estimated that would have cost $2 trillion to clean up. And I guess we wouldn't be on Facebook for a while or doing these meetings. Okay, so onwards. I thought this was an interesting article I ran into because I love watching how the universe works, and there was an episode there with planets made of diamonds, but those were pure diamonds. They were from a different process. But it's postulated that in some carbon-rich environments, the exoplanets could have a large amount of diamonds or contain a large amount of diamonds. So you can tell whether a system is carbon-rich or carbon-poor just from the star, and then you can posit that the planets there must be made of similar material. And then you can posit what kind of conditions would be required to produce such materials. And basically they tested it in a lab by using high pressure, high temperature, and water and carbon, and actually produced the material, loaning credence to such a theory. And below you can see a diagram here kind of showing the mantle and where all the diamonds are and so forth. Our Earth, by the way, is in a carbon poor environment, and it's only 0.001% diamond. So, but it's an interesting thought, and maybe for future mining corporations, way in the future, of course. Okay, now this I found really bizarre. Like, could there be life in our sun? I think it's good sometimes to think outside the box, because a lot of time we're looking for life, we're looking for carbon-based life, yet there could be other types of life forms. Even on Titan, it's speculated that there might be other types of life form or stuff, but this is way out there. It might have been inspired by Robert Ellsford's science fiction story, The Dragon's Egg, which posited nuclear-based life forms on the surface of neutron stars. So enter some crazy scientists with a bit of knowledge of cosmic strings and magnetic monopoles, saying, hey, under the right conditions inside a star, these things can form complex patterns which contain information and can self-replicate. So, hey, maybe that's the basis for life. Well, with these types of things, I tend to assume that the audience isn't aware of what magnetic monopoles and cosmic strings are, so I like to sometimes just provide a bit of enlightenment. They are, especially cosmic strings, they're rather abstract objects, but if you have any knowledge of, like, say, superstring theory, for example, you know, existed in 10-dimension space-time in the early universe. As it cooled down, you got these artifacts or deformations, just like in superfluids, you can get trapped magnetic fields. You get these string-like objects. They're one-dimensional strings, but they're artifacts as the space cooled into 3 dimensions, and they're left over. Cosmic strings were predicted, of course, well before superstring theories are just based on symmetry arguments. So these things have been around for a while. We haven't found them, but well, therein lies the possibility. Magnetic monopoles are interesting because if you look at Maxwell's equations, they describe, you know, the field equations for protons and electrons. Yet within those field equations, there's actually room for magnetic monopoles. So this is a magnetic pole, it has a north and south, but you never find north and south separate. And that's something to do with the intrinsic atoms and so forth. But it's postulated that perhaps there are particles that are just separate north and south poles. Again, we haven't found these, but we certainly have a theory that a rigorous framework that we can put them in as part of Maxwell's equations. So if you can take 2 of these abstract concepts that we haven't found, and then say, okay, hey, maybe we could also create these life forms in stars, but you can see how far-fetched it is, but yet you never know. So I figured I would throw that in there, and it was rather interesting, but yes, I'd say way out there. Okay, so moving along. I have in the past, I've given a lengthy talk on dark matter and dark energy and so forth. So every now and then I do bring up these subjects. That should say Hubble data and not Huddle data. I'll fix that later for my own thing. But basically, gravity, I'll explain this concept in a minute again, but you can see here these kind of weird shaped galaxies, and basically that's due to gravitational lensing. They're galaxies be in the background of the other galaxies, and because of dark matter in there, where you will see eventually this blue will sweep over the image, and that shows the dark matter distribution that's producing enough mass to create these ringlets, which are called Einstein rings. So what they've done is taken Hubble data and very large telescope data and measured everything in this system, all the gravitational lens effects on a large scale and small scale. They found tiny ringlets, and they used that to figure out where the dark matter was distributed in order for that effect to occur. Then they ran numerical models and did a comparison based on what we understand. Turns out there's a discrepancy on the small scale compared to the large scale distribution of dark matter. So there's might be some component of dark matter missing. So now I'm going to spend just a bit of time going into that, partly because someone asked me a question last week, which I don't think I answered really fairly because it was a rather lengthy explanation that would be required. So there's quite a bit of history behind dark matter and dark energy. So it's difficult sometimes to answer these questions very quickly. So I'm just going to quickly go through some little excerpts. So measuring dark matter. Well, first off, just quickly, you should understand how Einstein's theory of general relativity works. And a perfect example is if you go on YouTube, you'll find these videos of a rubber sheet model where someone puts in a bowling ball, throws marbles, and they go into these classical orbits. So basically the mass of a body distorts the space and time around it, and objects that enter the system that are less massive end up trapped in orbits. And these theories have been proven. The bending of light, which was the Eddington expedition in 1919, where they knew where the star should be behind the sun. And during an eclipse, they actually saw the star where it shouldn't be, and so concluded that there was a deflection of the rays around the sun for them to be able to see it, thus proving Einstein's theory of general relativity. This was from a Halloween talk, so I guess I see an Easter egg left over in here. Okay, so basically, if you have a large object here and you're sitting here looking at it, the light coming from here gets bent in both directions, and you see these ringlet objects depending on the position of where this object is. So if it's dead center, you'll get a ring. If it's off center, you'll get other stuff. This is the famous Hubble smiley. So doing that in a more complex system, you can model where the dark matter should be to produce those Einstein ringlet effects that you see here. Okay, so that's one side of the picture, how you measure it. The other side is a lot more complicated, and I'm just going to go through it quickly. Again, this is from a more lengthy discussion. I throw this in for context. They're way back when there are dark matter candidates such as brown dwarfs and many mini black holes around the solar system, but a lot of this around our galaxy, but a lot of these have been ruled out through what was called gravitational lensing experiments, looking at satellite galaxies such as the LMC, and finding that the distribution in events was so low that these things did not contribute a lot to the dark matter. So these modules or massive compact halo objects contribute very little to dark matter to contribute to it. So that actually answers a question from last time. So more likely people think it's particle-based. I'm not going to get into too much detail, but this is the standard model of particle physics. You are familiar with electrons, neutrinos, and quarks, up and down quarks. You're familiar with photons. maybe not so much gluons and W plus minus bosons, but these are the particles, fundamental particles that make up matter as we know it. These are the particles that cause the interactions, such as light and electrons. Light comes from shaking electrons, and the Higgs boson, which is to give mass. Now, the superstring inspired model, as the universe cools, produces this spectrum of particles, but as well as supersymmetric particles, which are much higher and, don't interact as strongly with matter. And these make up what we could call wimpy matter or other dark matter candidates. So the interesting thing then, I should just mention that there are tons and tons of theories of dark matter, and I have my favorites. The interesting thing is that although when they talk about dark matter, they think of one particle, there's no reason why it can't be other particles. So this is an interesting turn of events going, oh, there must be not just one dark matter particle, but there might be other types of dark matter particles that's causing this localization effect. So, okay, so I guess that fills your head with too much information. So I'm gonna go to something lighter now. I thought this was interesting. I went to a NASA website and I found these interesting, I hope you can hear that. Can you hear that? Yeah, okay, so this is actually quite interesting. These are, basically you have the Earth, it has a magnetosphere, then it has particles coming from the sun, and it cause plasma, northern lights and yada, yada, yada. But it's a very complex system. And depending where you are, if you have the right equipment, you can pick up these sounds. So these are coarse waves that are happening in this part of the magneto system, if you want to call it. And basically, when you have infalling particles, I'll just turn on the whistlers here. Depending where you are, you have different interactions, and they produce these different sounds. And it's actually kind of here to listen to and read about on the NASA site. So I was carefully reading it and trying to place these sounds on the diagram, but it wasn't very well explained, so I have to think about it a bit. So these are occurring in the lower atmosphere, the whistler waves, and I think you can hear some lightning in there too, so they're kind of mixed in there and they bounce around. Then there's these hissing ones up higher, okay? Get this wave sound. So it tells you basically when you have charged particles interacting with matter and everything else, you get all these weird sounds. And then this is the day-night transition sounds. So you get electrons and stuff hitting the atmosphere or whatever as you go from night to day. So it's actually quite interesting. So you can actually listen to all these sounds. Trying to turn it off here. There you go. Okay. I guess it's being stubborn. There we go. Okay, so I thought that was an interesting way to end everything, just sort of a more light thing, but it's actually quite fascinating, and the magnetosphere is actually quite complex, but very interesting. Okay, so that's the end of my eclectic mix of subjects for today. Any questions?
Yeah, Darren has one here. So Darren, go ahead.
Turn on his mic.
Okay, can you guys hear me?
Yeah.
All right. Yeah, Michelle, I was going to do it typing, but I'll do it by audio here. The bulk of those frequencies, are those like very low frequencies or extremely low frequencies, like well below the radio that you're hearing there? Just curious.
I don't know. I haven't really investigated it. I'm just trying to think how they would produce those sounds, because they're not.
Well, they might be doing an audio
Yeah.
equivalent to make it, audible for
Yeah.
people. But I was just wondering what the frequency range of some of these were. I'm assuming they're either extremely low or very low frequencies. So we're talking wavelengths in the ranges of hundreds or tens of kilometers, I'm guessing.
Well, I would say, well, the electromagnetic interactions are in the KeV range. I'm not sure what that translates into frequency. Probably megahertz. My guess is, yeah, somewhere in the microwave to radio range. I would imagine they're in that area. That's
Okay.
roughly where you would get those
I'll
kind of
look it up.
interactions. Yeah.
Appreciate it. Thanks.
Yeah. Any other questions? I see one on the Q&A. What generates the sounds?
Yeah.
Okay, so let's see if I can give an example. Okay, so let's see. Okay, so you have magnetic field lines that go around the Earth like this. And when a particle travels in a magnetic field line, it spirals in one direction if it's positive, in the opposite direction if it's negative. So you have these things spiraling around the magnetic field lines, and then you have a plasma of particles, particles in the atmosphere and so forth. And if they're falling into the atmosphere, there could be an interaction that produces electromagnetic radiation, and that you can listen to and get these different sounds from. So you could get a mixing as, it's almost like a charged fluid. So you could get a mixing as one goes from to the other. It could be like whoop, whoop, you know, like one fluid pushing against. It's like, yeah, taking oil and water and trying to mix them into the boundary. You can see how they mix. And then you could try to imagine some kind of sound going on as they were mixing because there's an interaction. Well, it's kind of like that, but on a larger scale with plasma, different plasmas, different densities interacting and producing these waves. That would be the best analogy that I could give. And because the entire magnetic system around the Earth is complex, depending where you are, you will get different types of sounds. That's the best explanation I can give. The NASA website does give some explanations, but it's even more vague than that. So, any other questions? I don't see. No, I see no other questions popping up.
Okay, thank you, Michelle. That was great. Oh, I think that's it. Okay, so we'll move on.
Okay.
There we go. Okay, I'm going to start with mine, if I can locate it. Okay, so there, I had it up. All right, so thanks everyone for joining up again. Sorry, I started the recording a little late. Okay, we'll make a quick announcement. So this is our Zoom meeting for September 11th, 2020. Okay, so let's start up. Of course, again, the university, I have to mention this again. Unfortunately, the U of M is closed to everyone well into the next year, including the open house. So it looks like we're still going to be using Zoom for a while until maybe a vaccine is made up. Okay, I did find out something unique here, something new. So Old Comic Marsh is now open. Apparently, Jerry will be doing a presentation there. It will be an indoor and outdoor presentation. No telescopes are needed, of course, because of the COVID-19. But apparently they were closed down because of repairs, according to Jacques there. So yeah, so next Thursday at 8 o'clock, there will be a little astronomy night. And of course, we have our Facebook account here. I have to mention it because a lot of people are using it more and more. Great, especially Sylvia. Sylvia was posting some of the pictures from her event. And again, we'll show it again here at our meeting. Of course, we have our Instagram and of course our website too. ASCO sketching. Okay, so Sylvia asked me, I'll try to promote the event here. This is a great way to get outdoors. It's very different. You can sketch, and of course, you don't. There's some rules. There's no rules really to sketch. You can follow her rules. They'll guide you, but I'll let Sylvia explain more about it. But if you want to join in, just RSVP her at this email. Again, you can find out more about it on the Facebook or on the forum at our website. Of course, you have to be a member in order to log in. Star Party pictures. This is something I've been trying to work on for the last couple of weeks. I know Jay wanted me to get some pictures on the website. I ran into some problems last night. I was hoping to get a link out for you guys on the forum. I got this approved by the council, and eventually these pictures will be posted on the website under the gallery in the Spruce Woods tab there. So eventually these pictures will be permanently posted on the website. But for now, I was hoping to get it out a little faster with my cloud but I ran into some problems last night. I can't believe how many pictures I have for the last 10 years. And there's so many pictures, and this connection I have at home is quite slow. So anyways, Glenley Observatory, a lot of people have been asking, especially the newer members. Of course, I'll be happy to do a tour. You can always reach me with my email, phone number, or on the RSC list, or on the forum at the website. I was going to do a members night, but the forecast for tomorrow looks like it's going to be partly cloudy, and it's going to be, looks like it's going to be raining tomorrow night, so I'm going to have to cancel it. But next week, because the Star Party's been canceled, I'm hoping to get out more. Of course, I'll let the people know through the RSC list and forums that when I head out, you're welcome to join me. And for those new members been asking for a little tour, I'll do a little tour. Mask is optional, of course. So, and of course, we have the virtual Boston Pizza for tonight. Probably one of the safest ways you can get together. Okay, so we'll head off with Sylvia. Let's see.
Hello, can you hear me?
Yes, I can. Let me get. Oh wait, I'm doing it. That's right.
Yes.
All right.
Put the presentation on, and I'll let you know when to move.
Okay. All right.
You're quiet there, Sylvia.
What's that?
Your voice is lower for some reason now.
Oh, is it? Okay. How about now?
Not much
How about
improvement.
now? Oh, I don't know why that's happened.
There we go. That's good.
Can still hear you.
Okay, turn up your volume, everybody. Let me know when I can start, Brian.
Okay. So, don't you see the presentation right now? I have it up.
No, I don't see it.
I don't see it either.
Oh, really? Did you guys see my presentation on the Zoom or?
No,
No? Oh my God. Okay.
we see you.
All right. Oh, right. There we go.
Here we go. I see it now.
Okay.
So put the first slide on.
How's that?
Oh, yeah,
Good.
there we go. Okay, so can I go ahead now?
Go ahead.
Okay, everyone, just a quick update on the astro sketching workshop that we started. We got together for the first time just last Friday, and it was really last minute because, you know, with astronomy, you have to plan, you have to take your chances and take every opportunity you can. So Friday was a beautiful day. It was good seeing, it was warm out. So I sent the email out to those of you who registered for the astro sketchers, and 7 people showed up. And you can put the next slide, Brian.
Oh, sorry. There we go.
Okay, and there's a picture of, we got together at Glenley Observatory on the cement pad with everybody with their own instruments. And Ron took this nice picture. You can tell it's actually nighttime. It looks like daytime, but it's nighttime. You can see the stars. And next one. So Jerry and I set up the projector with a screen on the side of the observatory there, and we all sat outside, physically distanced. Some people had to wear masks. It was perfect, and we were able to give a presentation to basically answer the question of why do we sketch? Next. Oh, and here's a picture Davidian sent in of the observatories, and the sketchers were just arriving. Next picture. And here we are, we're all wearing masks. When we couldn't socially distance, we put on our masks, except I see one person did not wear a mask. They're gonna be in trouble later. No, I'm just kidding. Actually, everyone was great, and we were really careful, you know, not to get too close, not to share equipment and things like that. So it worked out really great outside. Next. So here's some of the sketches that people sent to me to share, and they're simple sketches, but they still give us the opportunity to talk about more complex qualities of what we are looking at. For example, we're looking at Jupiter, and something that was observed is that Jupiter is not really round. It's actually flattened at the poles. So that was one of the things that we saw. Another thing was, sketchers were saying that how you can tell the planet is rotating because some of the items on the planet were cruising along as, from the time you started the sketch to the time that you ended the sketch. With Saturn's tilt, for example, as exemplified here by the astro sketcher with its rings open towards us, it explains why on Saturn the moons don't behave like they do on Jupiter, where they nicely travel across the planet's disk. With Saturn, because of the tilt, you're not able to see that. So these are observations that you do when you sketch something, things that you think about. Next. Oh, we also did a guided sketch of the constellation Cassiopeia. The sketcher here put the orientations in, the compass points, and also they observed Carolyn's Rose, a very large open cluster in the constellation of Cassiopeia. Next. Oh, this is Jupiter. This is my sketch, which I really tried to show how the planet is not round. So I tried to correct it, and it turned out more like a potato shape. But really, the more I tried to fix it, the more potato shape it looked like. But another one of the cool things about this sketch is that as we were looking at Jupiter and we were all sketching it at the same time, Jerry was giving us information about the moons and about the magnitude of each one of the moons. So with that information, we were able to identify which was which. And actually, Jerry is here today too. A special guest. Next picture. With this one, the sketcher was actually able to see two festoons and a barge on Jupiter. And what's really cool about this is that the sketcher didn't bring a telescope, but they were able to use the house telescope, which Brian has stored in the worm room. So if you ever want to go to the observatory and you don't feel like packing away your telescope and eyepieces and all that, just go down there. If you have a key for the worm room, you can just set up the 6-inch dot. It's a wonderful scope. The views that we had of Jupiter were really nice. And it also comes with a lot of eyepieces and filters, so you can have a lot of fun with that. Next picture. And here's the last sketch where the sketcher actually saw two barges on Jupiter. But see, everyone did consistently see that large barge on the bottom band of the planet. And another thing that was really peculiar about this one is that he was able to see that really thin line across the center of the planet, which is something unusual. And so that concludes that. And I just wanted to let everyone know, if you wanted to join the Astro Sketchers, you have to let me know so I can put you on the email list. I will send an email just before we go. It's going to probably be last minute because with astronomy, that's how we plan things. And don't feel bad if you can't come. If you come, that's great. If not, don't worry. We will have many more of these, so you should be able to make one of these events. And I'd also like to thank Brian. Actually, Ron mentioned on the email list how awesome it is to be at the observatory, because the worm room is equipped with drinks, hot water, and water to drink. It's got the telescope, it's got everything in there, and we know that there's a lot of effort from a lot of volunteers, so thank you. And thanks to Gord too for making the Astro Sketchers forum. So if you would like to see more about what the Astro Sketchers are doing, you can go to Facebook, but you can also go to the forum. There's a special section right at the bottom called Astro Sketchers. So if anybody has any questions or if you would like to join, just send me an email or a little message and I'll add you to the list.
Okay, thank you, Sylvia. That was great. We also have a computer in there too as well, so everyone's free to use that. All right, we'll move on. Jay, you have what's up? I'm going. I do. All right. So are you able to share your screen?
Oh, yeah.
Okay, perfect. Okay. You have the screen.
I see that. I just need to get this program to behave itself. Doesn't like, come on. There you go. Okay, September, October. Well, in some respects, this is the best time of year for doing observing outside because the darkness comes on early. The temperatures aren't too bad. The mosquitoes are gone. The nights are longer. And everybody is looking at that cold winter coming and realizing there's not going to be a lot to do once it gets below the 0 degree mark. Okay, sun today, nothing happening, but we have, you see in the lower left corner there, an ultraviolet image of the sun. And you see that little bright spot toward the bottom left there. That is actually an active region on the sun that was thought it might turn into a sunspot, but it never did. And look, yesterday's measurement of the K index, which is a measure of how disturbed the Earth's magnetic field is. And if there's a solar eruption, it gets very disturbed so that anything above 4 is, a warning is issued. You can see that through the 9th, 10th, and into the 11th, it was down at 0, which I haven't seen a 0 in the K index before, although they're probably not totally unknown. So the sun is extremely quiet at this moment. Well, look, Jupiter and Saturn, of course, as Sylvia showed us from the pictures that, the drawings that were done, they're very prominent. Low in the south, unfortunately, but they're there all night long and they're bright and they're impossible to miss. And after tomorrow or day after tomorrow, they will stop separating and start to come back closer together when they'll finally get to their closest point just the day before Christmas, where there'll be 1/10 of a degree. For those of you trying to figure out what 1/10 of a degree is, well, the moon is about 1/2 degree across, so that'll be something that'll fit easily within a telescope. The really big story in the next month is Mars, which is coming to its closest, brightest, and biggest position in the sky. Not as big as the moon, I'm sure we're going to hear about that. And magnitude's brightening up a little bit more. You can see that it's actually going to be brighter than Jupiter by the time we get into October. And the size is getting up to 22 arc seconds. So that's a very nice size. It's not the biggest Mars has been, but it's pretty decent compared to what we've seen over the last decade or so. So tonight at 4:30 a.m., it'll be at its highest point in the sky. By the time we get a month from now, in October 11th, it'll be 2 a.m. And so those basically tell you that if you want the best view of it, those are the times you'd have to be out. Although certainly any time after it's risen substantially, say from 10:30 or 11 o'clock onward, it'll be high enough in the sky to get a pretty clear view of it if the atmosphere is stable. And with these cool temperatures coming in September and October, there will be nights where the air is very, very stable. Typically, you might even look for a night with a lot of dew or with a little bit of fog, or you might have some trouble with your optics unless you warm them up. A couple of pictures of Mars taken off of the web from a few days back. And you can see that the polar caps are small but visible. And although you may not be able to see this level of detail on Mars, unless you have a pretty large telescope and a very good night, you can certainly be able to see the polar caps because they stand out pretty dramatically, even in small telescopes, once the air stabilizes. Mercury is in the evening, and it's actually quite a long distance from the sun, but because of the way the ecliptic is angled, it's pretty low in the sky for us. This is really a view of Mercury that's best in the southern hemisphere. Venus is up in the morning, impossible to miss, brightest thing in the sky in the morning. And it's passing underneath the Beehive cluster. It did that last month and the month before, but it gives a nice little addition into the photograph you might want to take of it. It's going to be getting lower in the sky over the next month and gradually fading back toward into the sun. Uranus is up, well, by the time we get into October, all night long. If you get a really dark location, it's a little over a 5th magnitude, which is possible if you've got good eyesight. You might try a little finder chart like in the journal and see if you can spot the planet and draw a picture of it so that you can see what star moves over a couple of nights, and be sure that you've actually got the right one. Neptune, you won't see by eye. You'll have to use a telescope. And there's not much to see on the telescope view of either Uranus or Neptune. They're both pretty bland. Sky tonight, you can see the Milky Way is, this is for about 10 o'clock tonight. Milky Way is well positioned. We've got all of the goodies from the Scutum-Tar clouds at Sagittarius down in here, all the way up through Cygnus and the North American Nebula, and gradually fading out a bit in Cassiopeia. But even here, some interesting objects to look for. We have the summer triangle of stars from Deneb and Vega and Altair in here, so that kind of marks the summer for us, although it's really most visible here as we start to squeeze into fall. But as the night and the month passes, another formation becomes a little more prominent, and that's the square of Pegasus over here. There's not very much in the way of deep sky objects in the square of Pegasus. There's some galaxies and things like that, but the square of Pegasus is fairly easy to spot and becomes not as dramatic as, say, Cygnus, the constellation here, or some of these other ones, although the really good ones down low are too low for really good view from us. But you'll find that you recognize the square of Pegasus quite readily once you know what to look for. And of course, Cassiopeia. The other thing, we start looking for the prominent objects that come out. One of them is the Andromeda Galaxy, and I find that here's the constellation Cassiopeia, the W shape, and you can see you've got a rather broad V on one part of the W and a very pointed V on the other. If you follow that pointed V, you come down to this star in Pegasus or Andromeda here, and you go straight up from that to another star. These two are pretty easily visible by eye, and you go the equal distance up and you'll hit the Andromeda Galaxy above it. So coming off of Cassiopeia down to this star and then upward is a very quick way to find the Andromeda Galaxy, which from a place like Glenley you should be able to see by eye. But equally interesting, or almost as interesting, is exactly the opposite direction and the same distance you get into the Triangulum Galaxy M33, which is tougher to see, and which I've found is often easier to see in small magnification or even binoculars than it is with, say, high power binoculars or small telescopes. It's kind of a diffuse object, so it doesn't stand magnification very well. So that's kind of the other way to find it, is to come across the square of Pegasus from one corner to the next, and that'll get you pointing into the right area, a little less than the distance across the square. So certainly being able to find Andromeda, because it's so easy with these pointer stars, should be something we're all pretty adept at after we found it once. We get into October. I've picked the 1 a.m. time period because the Milky Way arches across the sky so nicely, but to get a picture like the planetarium program showing here, you're going to need something like a fisheye lens. But the important thing about 1 a.m. on October 11th is right here in the middle, where Mars is at its highest point in the sky for that night, and it's at its closest point to the Earth. So sometime around a month from now, if you spend no other time looking for Mars, then you should do it in around midnight on that night. I suspect we might even be able to organize something at Glenlee when Mars is at its best and get the big scopes out and pointing at it. You can see here a list of some of the other things. The Andromeda Galaxy is still up, pretty high up in the sky, and will be for the next several months here, almost overhead. In fact, if you have a Dobsonian telescope, it's difficult to see it when it's up in there. And we have the Pleiades star cluster and Orion here that are also coming up in the morning sky as well. Pretty pictures, Venus and the Beehive and the moon on September 14 in the early morning. So here's the Beehive cluster, Venus here, and a very thin crescent moon. Would make a very nice picture with a small lens on a camera. Moon's passing under Jupiter and Saturn on the 24th and 25th, but it's not very close to them. October 2, we have a full moon passing underneath Mars. Here's a diagram. So it's about 2.5 times the diameter of Mars, or of the moon, 2 times the diameter of the moon. And October 3rd and 4th, Venus is passing just under Regulus, less than a degree passing through here. Regulus is the bright star in Leo, which is the backward question mark. So that's also a constellation that's pretty easy to find in the sky. But of course, all you have to do is find Venus, which will be shining brighter than anything else, and you'll be able to see Regulus right beside it. The zodiacal light is back again now for the fall. The handbook has an error to some extent. It has the same apparition of the zodiacal light for both September and October. So somebody cut and pasted. But anyway, it will be visible in both months. But it tends to be best as we get toward the end of September. So the zodiacal light is the reflection of sunlight off of gas, or dust rather, that's in the same plane as the orbit of the Earth, or the plane of the solar system for that matter. So sitting on our Earth here looking not at the sun, because we wouldn't see it, but off to the side, which means in the evening or in the morning, and in this time of year it's in the morning, you should be able to see the sunlight reflected off of that dust. In really dark skies, you can actually see the zodiacal light stretching right across the sky. So here's a couple of pictures. This one on the upper right is one that I assembled from 16 25-second exposures. You can see that's a Rebel T1I, which is a pretty old Canon camera, 12mm lens, and so on and so forth. The interesting comment here is a program called Sequator, which I used to assemble it. And I'm going to talk about Sequator in my presentation about some of the photographs. But Sequator is a free program that I think a lot of us could really use to make some very interesting pictures of the night sky. So we have the peak of the Draconid meteor shower on October the 7th. It's not a big shower, 5 to 7 per hour, but every now and then it goes bananas. And 600 in 2011 when it was over Europe, and much higher rates if we go further back into the past. The radiant is actually a little bit above the North Pole. The best way to find it is to use the pointers Altair and Vega from the summer triangle and just go straight up till you hit these two stars in here. But we don't really want to watch a meteor shower looking at the radiant. We typically like to look off to one side. So above the Big Dipper, under the Little Dipper, somewhere in there would be a good place to watch. And because you're looking north, probably want to do it from Birds Hill Park rather than from Glenlee, where you'd be looking over top of the city. The weather, here's what we're looking like. A little bit of clearing in the evening tomorrow. Sunday night looks pretty good. A little bit of precipitation on Wednesday, but up and down in the sky cover until we get up till a week from Monday. And you can see the temperatures are up in the 20s and then they fade away. But it's no real shot at cold weather, and there's still some warmish days coming along, even getting close to 25 here. although these are computer generated forecasts, they're not human modified and probably give you a trend more than actual values. And here's the cat. Thank you very much.
All right, thank you, Jay. That was great. Do you want to take a few minutes before you start your next presentation, or?
Well, let's see. I got it sitting right here on the screen. So,
you want to start then?
Well, if people are not tired of hearing from me, then yeah, we can start this up. So, take a breath. So I sent out a note asking for people's pictures. Originally, this was going to be images of the comet, because I think more than any other event we've had in the past couple of years, this comet got people out in the night to have a look at it. It's certainly one of the best comets since Hale-Bopp. And it did a very nice job by being circumpolar, which was both an advantage and a disadvantage, because it meant that it was always near the north horizon, which was quite bright in July and August. But at the other hand, it made it easy for us to find it, because all you had to go look straight north and it was right there. Where is it? Where is it? No, you need to go out and, oh, there it is. So let's have a look and see what we've got. Well, I thought I'd start off with a little bit of humor, but more appropriate for it is you've got to have a comet humor, or an asteroid if you want, particularly the one on the right here, because this was something you had to go out in the night and see. It was easy to see, and yet I'm amazed at how many people never really saw it. Even in cottage country, where I rented a cottage for a week, there were people who all they had to do was look out the door before they went to bed, and they just couldn't be bothered. So in a way, if you went out and saw the comet, then you saw something that most of your fellow human beings didn't see. So here's a picture from Curtis Christie that's fairly typical of what the thing would look like to the eye, with a little binocular help. But when it was at its brightest, that's about what you would see if you just took a look out. You can see that pretty simple exposure, a little over 1 second at 135 millimeters, sort of standard picture that you can get with just about any camera. And I've even seen cell phone photographs that would probably do justice to this image as well. I think the clouds always add a little bit into these comet pictures because they help to frame it a little bit. Here's a picture, and of course, when everybody in the world is photographing the comet, then being able to frame it in something, and we'll see some very nice example of that from Sheila later on. But here, I think this was by Judy. My captions are hidden behind the picture of all of us on the screen here, but it's just one way of making it a little more presented by putting it in a frame. We've already seen the picture on the left from Sylvia, and there's a different picture there on the right that is, I've left it in the original drawing format. There's black on white paper. The one on the left has been inverted and colored by Sylvia. And I noticed that she's got all of the conditions laid out in there. July 20th, 2020, 1 a.m. at Jerry's in Toulon. Observed a very uniform dusttail without much detail in it, soft white color, diffuse coma, and definite brightening towards the center. Hints of blue-green. These are the kind of notes that are actually quite valuable when you go back to looking at what you've drawn later on. Now, nobody's going to ever forget this comet and where they saw it, that sort of thing. But if it were a galaxy or a nebula or a planet, then that sort of information would be very good as a reminder to you where you were and what you were doing. And on the other side here, we have one from, let me see if I can read this. Shoal Lake, oh yeah, right on top. So this one's from Shoal Lake. I like the stars in the field of view. That really helps you place it underneath the Big Dipper and so on and so forth. You don't need the camera. In fact, sometimes I think you get far more out of a picture like this than you do when you just push the trigger. Here are two pictures from Sheila. One's a blow up showing the isochrones in the tail with the streaks that are individual outpourings of dust that have collected along a certain part of the orbit. And then the ion tail or gas tail that's in blue that stretches out in a straight line. So the dust, the white tail, is stuff that's in orbit, and the ion tail are ions, ionized elements that are blown back away from the sun by sunlight, so they follow a straight line backwards. They're not influenced by gravity. And Sheila has the same thing, a little church over by Calliope, where Steve and she are staying, and now they've moved into it. And so she's illuminated the church both inside and outside. The church is never locked, and so it's quite easy to frame the comet, and nobody's going to bother you because it's so dark out in that location. You can see her comments on the bottom. Here we have a picture from Daryl Moth. Daryl, are you with us?
Yes, he is.
Yeah, why don't you hook him in and ask him if he wants to say something about this.
All right, just 1 second.
If he's listening, he might be muted.
Okay, can you hear me?
Daryl?
Hello? Can you hear me?
Yeah, we can hear you.
Okay, perfect. Thanks, Jay. My name's Daryl Mothy. I live out in the country, just a little bit east of Lorette, so fairly dark sky. So I was, you know, like everybody else, trying to take a picture of, or find the comet and take a picture of it. And I happened to be setting up my camera on the night in question, and just was snapping some test images, and I didn't, at that point in the night, it wasn't quite yet dark, and but all of a sudden, you know, the comet showed up in my camera images, and so I got really excited. I thought, well, this is great, but I snapped, I don't know, probably 100 frames that night, and this was one where just around midnight, the aurora was, you know, started illuminating, and I just happened to be there with my camera, and I was able to take a couple of pictures of it with the comet in the background. So was pretty fortunate, and you know, that's the result. I did see on the web afterwards, a few other people around Canada all managed to capture the comet with the auroras in the background. So
Thanks, Daryl. Here we have a couple of cell phone photographs. I asked people to send me cell phones pictures, and certainly Judy has what is this, 12 now or something like that, that took pretty good pictures of it, although she had a regular camera as well. But I'm quite impressed by the sensitivity of these cell phone cameras now. I think just about anybody with a cell phone could probably do a little bit of astronomy. And when I talk about that program, I'll show you how you might want to be able to really get something quite dramatic. So This is from Kathy Davis, and Kathy's a pretty good photographer, but she's took these one on the spur of the moment with her cell phone and sent them along to show us what it could be done. Andrew McCaskill, no slouch, he took long exposure, 30-second pictures with a 300 millimeter lens. You can start to see some of the structure in the center of the comet head, the way that it flows back from the head, and a little bit of detail in the tail itself. But to really pull out detail in this tail, you probably have to suppress the brightness a little bit. And it depends on how you process these things, on what kind of level of detail you can see. I know, while I don't have any here, Judy took some 600 millimeter pictures of the comet head at very, very short exposures, sometimes much less than a second, just to see if we could see any detail. There's things to be seen, but not the greatest. Kevin sent along, let me quit playing with this. Come on, give me back my, don't play with the wheel on your mouse. Kevin sent along this picture of the comet in glowing green, but with everything else that was in the field annotated, which I thought was it's a good picture of the comet, although the color's a little bit unusual. Comets are definitely green, but you also see how a fairly standard camera can capture an awful lot of other things, although many of them just visible as a point of light. And so you can see a little better. I blew up a section or cut a section out, so you can identify or try to identify some of the little spots that belong to other elements. Not all of these things are actually visible in it. They're just extracted from a planetarium program, but other ones certainly are visible in the picture. Here's Andrew with a different picture of the comet, now showing the tail. Green color in here is actually the color that the nucleus of the comet, many people remarked on that, even visible by eye. And that's a fairly common color in comets. This is one of mine. I don't know why it came out red and blue like that. I think the reddish color is because it was just barely off the horizon and was shot while the comet was almost at its lowest point in the sky. So we have an large amount of reddening in the background. I think I'll play with that a little more. But this one, you can also see the isochrones in it and this sort of recent emission from the comet head at that point. I think it's probably a little over-processed. Bill McDonald sent along a picture from Hubble. So it give you an idea of what the nucleus of the comet looked like. Now you're not resolving the nucleus, it's still somewhere in this globe, but you can see emission going off in this direction and in this direction. So there's at least 2 points on the comet that are emitting dust and gas, and as those things increase and decrease in activity, they send out little bursts of dust that later go on to become those streaks in the comet tail. Here's one of Judy's. This is a Canon 80D 150 millimeter. All the stuff is on the side here. This is 7 images put together. A little bit of sky glow in the background, actually, that's not clouds. It's either sky glow or it's noctilucent clouds. I haven't quite figured it out. The greenish color suggests that it's might be a little sky glow, and there were some nights. These are a number of different exposures from a half a second upward, trying to see if we can get more detail in the very bright part of the comet. But it didn't do much more than most people's pictures of 15 seconds or thereabouts. Stan Runge sent quite a collection. I know Stan has got multiple photographs of the comet from day to day that he wants to sort of shows its changing appearance. You've got 2 on July 13 here and 1 on July 14. I won't say anything more about them. Stan, are you online?
Yeah, I'll put them online.
Yeah, let him talk about these guys. Got a lot of green in that right-hand one.
Hey, Stan, you're on?
Okay, can you hear me now?
Yep.
Yeah, the thing about the shots, the couple shots on the 13th was one was in the morning and one was in the evening. A lot of the time I started off shooting with the 600 mil because I like to get in close and the detail on the comet. I guess then I started to realize how far the tail went. The middle photograph is somewhat similar to Jay's, except it's not processed. These are all just unprocessed single frames. I haven't done any stacking, or I've just started stacking and such with them. But yeah, you could see in the middle image just a tad amount of the blue ion tail that Jay was talking about. So I'm looking forward to doing it, doing a lot of work with him. One of the things I do notice is that because I was shooting for long periods of time, like for hours, and shooting a lot of 30-second exposures for a couple hours, is that when this comet was closest, it moved a lot. So one of the things about trying to do the processing now is to try to grab a number of images that are of high quality in small little groups, maybe 5, 10 images that may have been done within about a 5-minute period, processing that, and then do the next set, and then eventually trying to combine some of those where you will use one of them as a reference frame and keep the stars from that one, and then you can do some of that sort of stacking in well, Images Plus is one of the programs that you can do stacking with it. Anyway, I've got images all the way from the 7th of July to the 28th of July. So I'll try to put those together soon. Okay.
Thanks, Stan. Here's a photograph from Sheila. She's got the ion tail, really nice. She just sent this to me tonight. And so very nice isochrones in the tail of the comet. Each one little outbursts of dust that went out at different times and have formed these bands where they're a little heavier dust than in other parts. And the ion tail even has a little detail on it. I've seen pictures that Steve has that are magnified area in here, and you can see little enhanced parts moving along the ion tail in the course of an hour-long exposure or a series of exposures over an hour. This is Judy's movie, which I think most of you have seen. She photographed the comet all night because we happened to be in a place where we could see it reflected in the river or the lake. So here it is swinging down low and then coming back up after it's past its lowest point. The bright star to the upper right of the comet is Capella. And so the comet was circumpolar, and right at the end of this, she changes the brightness, and you can see the noctilucent clouds forming along the north horizon. So she just shot, I don't know, 1,300 pictures or 900 pictures that night, and we put them all together into the movie. Took out some of the garbage that was in it, you know, the odd bright light that went by, or some, there weren't very many aircraft. That's one thing that the coronavirus has done for us. Then we took those images and took about every, I don't know, 30th one of them and strung them together so that you could see a sequence of the comet as it's swinging down low. And you can see the reddish color that, because it's so low down for us, which is what showed up in my pictures. If you waited a few days after this or at a different time and you photograph the comet higher in the sky, then you get the whiter colors that some of the pictures we've seen have. And people who were farther south saw the comet in a much darker sky because they didn't have the bright northern horizon that we do. So I use a program called Star Stacks, which is, I think, a free program. I also use Star Track to make star trails, and this is the comet right here with star trail of the comet. I didn't use the whole night. There was a huge number of pictures. This is some of the garbage that I mentioned. There's us illuminating things with red lights, but these greenish things are actually fireflies that were scooting around at the same time that we were trying to photograph the comet. So they showed up in an enormous number of pictures until about midnight, and then they all went to bed. Plus we have, I'm guessing that's a rotating satellite here and another satellite that's rotating here. And this is probably an aircraft that went by, and so on and so forth. I have a lot of fun with these things, just playing with some of the software. And we also, most of us had an introduction to noctilucent clouds as a result of being out on the right night, because noctilucent clouds have been extremely active this year. Been looking for them for 4 years and never saw them. And then this year I saw them on about 80% of the times I went out. Noctilucent clouds are the highest clouds in the atmosphere, up at about 80 kilometers. So they're only visible when they're illuminated by the sun, when it's below the horizon and everything else is dark. And Sheila sent some pictures this time in a morning sky with the noctilucent clouds glowing. The closer you are to sunrise, the lower in the sky the clouds are going to be. Now, we're going to talk about things that aren't comets. And again, in asking for cell phone pictures, Abdul sent along these. Abdul, are you online?
Yes, he is. Just a minute.
Yes, I am online.
Well, what do you want to tell us about these?
Well, this picture, I took them with the C90.
Mm-hmm.
And just one single frame of them, and it was from my backyard, so within the city limit. Time around July, like end of July, end of June, sorry. Just single frame, no processing, and that's all. Maybe different exposures, like a different ISO speed, between 400 and up, and like below to 100, or even sometimes 1600 I tried. Time within a few seconds, maximum 2 or 3 seconds for the planet. And I think for the moon, somewhere about maybe 1/10 of the second.
Well, they got an interesting picture of the new moon in the old man's arm there in the left side. And Venus is interesting photograph too. Pretty nice to see what you can get. Thanks, Abdul.
Thanks.
Here we have some other photographs taken, some older ones. This one, the Mercury transit. Kathy got a picture of a meteorite when she was doing star trails in the north from the Saskatchewan Summer Star Party. Again, these are iPhone photographs, and although they are looking through a pretty decent telescope, once you own the telescope and you have a phone, you also have a camera. So there are things you can do with these instruments along the way. The cameras are now so powerful that the biggest thing about photographing something through a telescope is just getting it pointed in the right place. And of course, the star trail photographs are taken on the tripod, just pointing upward at the stars. Some pretty faint stars there in the short exposures that a cell phone is capable of. Paul Paradis wanted to photograph the lunar X. The lunar X is one of those things that kind of happens at a certain time, and here's the lunar X right in here. And the lunar X is just the way a certain particular time in the moon's cycle when the sunlight rising on the peaks just beyond the terminator, illuminates certain peaks to make the X. And so Paul took this through his cell phone using a 5-inch Maxitov Newtonian. Good crisp detail on the moon as well. These are sort of fun things to take, but when you look at this as a photograph of what's happening on the moon, you could actually do a lot of discussion about lunar geology on just one picture like that. All the things you see in here and trying to explain what they are. This is a picture Judy decided to photograph the moon one day. We're at Assiniboine Park and she's looking west toward the setting moon, and that's also the flight path going into the airport. So I have no trouble with all these streaked out lights as the plane went through, but why do we have a sharp view of the plane's undercarriage? The only reason could be is that there was a strobe that went off at that point and illuminated the engine, nacelle, and the wheels here at that one instant. So this is one of those lucky shots or unlucky shots, depending on your point of view, of that you can get while you're attempting to do other things, an accidental shot. Gord sent some planetary photographs for us. Now, these are a challenge right now because they are low in the sky. And so Gord uses what's called lucky imaging. Is Gord online?
Oh, sorry, I'll put him online. Darn it.
He might not be paying any attention.
I'm trying to go through all the
Oh, okay.
people here, and I don't think I saw him originally, so I don't think he's here.
Okay, all right. Well, most of the details are written there in his comments at the bottom. Use a process that euphemistically called lucky imaging, meaning you take a whole bunch of frames and you pick the best of them to assemble into a composite, the lucky best ones. So here he is, got 5,000 frames. He's shooting a video at 5,500 frames per second. So that's 100 seconds of video, and then the program picks out the best of them. You tell it that you want the best 10%, the best 5%, or whatever, and then it will assemble them in this program, AstroStacker and Registack. And lo and behold, with a little processing, you'll come out with this kind of detail, which I think is pretty good for the altitude that these things were above the horizon. It's low for us. If you were shooting these from Arizona, these things would be 15 degrees higher. And if you were down in South America, they would be almost overhead. And but nevertheless, there's a considerable amount of detail and color in the Jupiter image, along with two of its moons here off to one side. And you can see the sort of edge of very fine detail here in the dark bands and the red spot and so on and so forth. Saturn, you're beginning to see Cassini's division here out on the edges and some structure in the clouds here in the middle. It takes, well, he's using a C8 for this, a regular without any kind of a Barlow lens to increase the focal length. So that's actually, they're both probably pretty tiny images in the C8, and that's pretty good processing. Pretty good level of detail. Jerry likes the other approach, though. He wants to draw, and this is Mars. And I don't know, Jerry, are you here?
Jerry,
Oh, there he is, yeah. Jerry, how high in the sky was Mars when you did this?
It's as high as it can get. It was about 45 degrees up. It was just past the meridian.
Was that a good seeing day?
Very good. I was up around 250 magnification, maybe closer to 300.
That's an enchanting picture, you know, because I looked at Mars myself, although not with as much magnification as you were using, and those details were much more subtle to me than you've managed to capture. I think it really illustrates the advantages of drawing what you see.
Yeah, for instance, that little bridged gap across the bottom there, that wasn't always visible. And if you'd have to go through an awful lot of lucky frames to finally capture that with a camera.
Yeah, I would think so. Oh, that's very nice. I think now we'll see what we can do as it gets the last month of its close approach, and got to get some people out there and put that big telescope to use out at Glenley to watch this guy. Thanks, Jerry. Here's a picture. I bought myself a filter to hook into this new camera I've got, and the filter cuts out ultraviolet and infrared light so that it forces the camera to only take a picture of visible light. And all of a sudden, the color purity that I was able to get came out a lot more decent. Now, this is the Omega Nebula, which is usually only visible as this part right in here, which has got actually a greenish color from oxygen emission. What I liked were these two NGC or IC objects in here, this one and this one. And to me, this is like a big bat or something like that that's flying in. I don't know. Anyway, I was pleased to see that so much detail came out of this, but it was quite a long exposure. But it made the difference. I had a lot of trouble with color correction in my photographs until I put the filter in to cut out the extra red and actually extra green light that comes in at the distant in parts of the signal. Abdul, we're back to Abdul again. I brought these mostly to show, he was just photographing constellations as a bit of an experiment, but I went and looked at this and he's getting stars here in these short exposures that are down to 7th magnitude. And what's also interesting to me is the colors in the star from a very simple cell phone photograph are showing up. So you've got red stars and blue stars and some yellow stars in here. So interesting that cell phones are able to keep these colors if the exposures aren't too long. And of course the coat hanger right here, a little well-known asterism. And another one, just an example of constellation photographs. These are actually nice to have because there are times when you want to talk to people about what you're seeing in the sky, and having familiar constellations to show them where things are and what they look like is very useful. Picture of M11, an open cluster. This is one of mine. This is a program. This is a Milky Way image, and it's 76 images in this 13-second image, and it was just taken on a camera pointing toward the east, southeast, as the Milky Way was rising. But what's interesting about this is 16.5 minutes, and if you're tracking the Milky Way, then the ground should be smeared out. But this was not a tracking telescope. This was just fixed on a tripod. So I found this program called Sequator. And what Sequator will do is it will take your image and you sort of roughly mark out where the sky is in the image. You paint it in, and then you tell it to hold the landscape constant, and it will freeze the landscape while the stars move, and then it'll bring all the stars back and reassemble them. So it's basically making a composite and stacking your images for you. And it's a free program, very, very simple. But it will also do, if you have a dark slide, it only takes one, or you can assemble a composite, but one dark slide and one flat, and it will get rid of the errors that come from hot pixels and the vignetting of your lens. You have to kind of explore the switches on it. But when you consider that this is a picture that anybody could take, you might not have a lens that covers this much area, but you know, 50 millimeter lens, you don't have to have the ground in here, but having the ground held perfectly steady while the stars move and then they're all put back into their position is a really, really nice advantage. You can see there's some green and almost purpley strikes in here and through here, which are signs of air glow on that particular night. So I expect to see a lot of people taking a look at this program and then just going out and pointing south from Glenley. It'll get rid of light pollution. It's all kinds of things. Pretty sophisticated program for something somebody's giving away. So go out and look it up, Sequator, and see how it's spelled there. And you'll find that it's a pretty quick download. Here's a different Milky Way picture, taken a lot of exposure on this one, 180 seconds and 10 exposures, 3 minutes each. So this was mounted on a tracker. Pretty garish. It's more experimental than anything else. Again, a Veil Nebula picture. We have several of those sent to me. This one is with the filter in place, though. I managed to keep a lot of color in the stars with this one. Kevin Galka sent along a lot of deep sky images, and you can see the selection here. Some of them are well known, like the Trifid here, or the M20 in here, Trifid, and M16 and 17 here, which are M17 was the one this one I showed you a little earlier, also known as the Omega Nebula, and a couple of lovely galaxies here, beautiful coloration in the red in the center, trending out to blue in the arms. The red center is old stars that have evolved, and the bluish arms are new stars that are forming in the dust and gas out there. So by keeping the colors in these images, you get a lot of information. This is an emission nebula here, where the gases in the cloud are being excited by this star, and they're fluorescing in red because they're mostly hydrogen. But over here, we have the blue light of the star being reflected from the nebula. So in this case, we have both an emission and a reflection nebula in the same place. Over here, we have a nebula with dust lanes stretching through it, but there's dust everywhere in the galaxy. You can see all kinds of dust wherever it's dark that's masking the light of the stars in behind. So both blow-ups and wide area shots are really nice for teaching you a lot about the way the stars work. And Daryl sent along a bunch too. Here is another part of the Veil Nebula, and you see the same sorts of colors. And again, this glorious colors, reds in the center and blues on the outer parts, depending on what kind of filters you use and how you process them. Markarian's chain is what this string of galaxies is called. That's a favorite object. Daryl sent me a lot of pictures, and I can't show them all in the time that we have here, but I think you get a pretty good idea if you've got some decent equipment. More than anything else, if you've got some decent dark skies and live out of the city, and you have the time to do this sort of thing, that you can really put together some spectacular imagery. And finish off with M13. I think I'm finished now. Globular cluster. Again, a cluster with yellow stars in the middle and reddish stars around the edges. These stars tend to be kind of old. This pinkish color that you get here is because of the extra light that's coming in, especially in the infrared. So I'm going to redo that photograph one day and put the filter on that gets rid of all of this extra red and green that gives it funny colors. So here we'll end. Now, I don't know when the next bright comet will come by. I think it's been about 10 years since this one, if you don't count McNaught. It's, if you have to go back to Hale Bop, it's 20 or 30 years, 25 years. So someday another one will come along, and with our luck, it'll be in midwinter. But, you know, we did see some really nice ones in midwinter when Yakataki and others went by. So if you missed this one, don't miss the next one whenever it comes by, because they are things that you remember for the rest of your life and you talk to people about. And if you got kids, you take them out and show it to them, because 50 years from now, they'll be telling their kids about the time they went out with granddad to look at the comet in the sky. Eclipses and comets are both like that. So thank you all very much.
Hey, thank you, Jay. I think that was an important thing, that everyone at some point was able to see the comet, and getting out there is the main thing. So before we wrap it up here, someone was asking me, oops, where is this? Hey, does anyone see this? This is a picture that Sylvia wanted me to show. It's the face that Jerry pointed out too. There's that little face there we saw on the moon. So anyways, it was kind of unexpected, but it was nice to get out there. That was through my my phone right there, through the eyepiece. So anyways, one other thing I'll show is, before I go, they want to see that? That's my comet picture. So that was nice. That was around 4 o'clock in the morning. So it was kind of nice to get out there. That was the only time I was able to see the comet. After that, I was unable to see it, and it just got dimmer over the past of the year, or over the past few days. Anyways.
Hold it, Brian. We're not seeing your comet.
Oh, really?
Still got your moon.
Oh, sorry. What is this? Just a minute. Really? Cancel. Oh, come on. I hope you guys aren't seeing that one. Why am I can't minimize it? It's not very, okay. There we go. Okay, sorry. Let's try this again. Crap. Just a minute. I'm trying to work on 2 computers here. Just 1 minute. There. Can you guys see that now? Jay?
That's
Yep.
good. That's
Okay,
good.
yeah, thank you. Sorry, it's just I'm working on 2 computers here. Okay, that was my picture, and I mentioned before, like that was the only good night I was able to see the comet at 4 o'clock in the morning. But okay, let's wrap it up there. I was going to maybe show something else too, but it's already 5 after 9. We'll move on to our Boston Pizza, the virtual Boston Pizza. Thank you for everyone coming out. Thank you for everyone that participated in showing their pictures. I think we'll do this again some other time. I think it's a great way to share, and I think it would be great to get more people involved, sharing, talking about their pictures. So we'll leave that for another time. So that will conclude our meeting for September 11th. I want to see if, nope. Okay. So anyways, thank you everyone. Okay, we'll see you at the Zoom virtual Boston Pizza. Okay, so we'll end it right there. Thanks.
I don't know what's part of this is me.
Oh my